Hello, everyone, and welcome to our partner webinar today. This session is being sponsored by Aeris Communications. And before we get started, I want to cover a few reminders on our console. This session, as always, is being recorded. So if you step away or miss any portion of today's session, you will receive a link in a day to view it on demand. Also, this webinar is interactive. We invite you to submit your questions at any time using the Q&A widget on your screen that's located right underneath the slides. When you submit those, they'll queue up on our side, and we'll get to as many as we can at the end of the session. And if we miss any of your questions, we will follow up with you after today. We also have handouts available in the handout section, so take a look there. Also, we invite you to the attendee chat. That's the section that you can bring up with the orange icon buttons at the bottom of your screen. That's second from the right. You can jump in and start a conversation with your fellow IT pros. Be aware to follow our community guidelines throughout the session. And if you have any questions, get those back into the Q&A widget. So with that, I do want to introduce our speaker for today. We have Zaid Z. Hossain, Chief Technology Officer at Aeris Communications. Mr. Hossain is responsible for the architecture and future direction of Aeris Networks and Technology Strategy. He joined Aeris in 1996 as VP of Engineering and is a member of the founding executive team of Aeris. Mr. Hossain has more than 38 years of experience in the semiconductor, computer, and telecommunications industries, including product development, architecture design, and technical management. So with that, I'll hand it over to you, Z.
Thank you very much, David. Appreciate the introduction, and I will go ahead and start going on this presentation for everybody. And the topic today is 3 mistakes to avoid when launching an IoT solution. The idea is that companies will be following a particular development process, and the mistakes that you can make in launching that kind of a solution is something I'd like to touch on. Obviously, 3 mistakes are some of the ones that I've picked, are some of the ones that we see from the experience that our customers have. And we will talk about some of them and what kind of solutions you might necessarily deploy to avoid them. But before I get started, let me spend a few minutes talking about the company, who we are, what we do, and why we have this experience. Basically, we are a technology services provider partnering with our customers to help them get from products that they are currently not deployed in a connected manner and using them to get into a connected service environment. The idea is that we will help them from our various locations around the world. We have our offices, our headquarters are in Silicon Valley and San Jose, with operation centers in Chicago, United Kingdom, India, Japan, and network operating centers in San Jose, Las Vegas, the 2 in the United States, London and Delhi. The solutions we offer is something called the Aeris Fusion IoT network for an IoT optimized cellular network. I'm not going to be talking about that or the Aeris automotive platform that is mentioned next. Those are other topics. One of the handouts, in fact, addresses the Fusion IoT networks. You can go get more information. Our customers have deployed units in a variety of different markets, ranging from connected cars, fleets, healthcare, financial, industrial IoT, utilities, and other areas where the IoT solutions that can be deployed to help those companies make a good deployment of their products into a connected service for their customers. In terms of the numbers, we have a robust history of growth. We have operational connectivity reach for our cellular services in 180 different countries, over 14.5 million devices on the network today, when we're processing well over 4 billion IoT messages daily today. In terms of the number of deployed cellular units, we're in the top 10 globally, number 3 in the United States, top 10 globally. Now let's dive right into the topics that I'm going to be covering today. IoT solutions, I picked 3 areas to focus on to avoid mistakes. One is in the area of security, the second one is in the area of device management, and the third one is in the area of scaling. By scaling, I mean how do you grow the solution, how do you deploy more units, and how do you manage those devices. But before I make any separate statements about each of those 3 areas and talk about the mistakes to avoid, let's get to a poll, because I think it would be important for us to know what the customers' experiences are, where they're at. So the first poll is, where are you in your IoT journey? Are you exploring? Is it, you can start clicking right now, by the way, please select one. Is IoT something that's currently in the exploratory phase for your business? Are you building a proof of concept already? Have you planned a deployment within the next 3 months, perhaps? Or have you already deployed and now you're trying to scale that deployment or increase the number of units you have out there, et cetera? We'd appreciate if you could select one, and we'll give people an opportunity to pick over here, and then I will deploy the results of that, show you the results of that poll in a moment. Okay, looks like the numbers of people who have responded has stabilized. I'm going to go ahead and go into the results and show you what the results of the questions showed. Basically, it looks like 9 responders said that they are currently exploring, and that's about 70%. And that's what we expected, because we're focusing this webinar to people who are just getting started, and they're building a proof of concept right now, or they're in the planning stages right now. So that's kind of cool. I hope I will be able to give you the information to make decisions about what to do for IoT solutions. All right, let's dive right in. First topic I'm going to cover is security. There are some challenges. IoT applications and devices that are out there have been targeted by the hackers. They're prime targets because of the number of units that are out there, and it's an ever-growing threat. You see daily reports in the media of what's happening out there. Another important point to keep in mind is that these devices are usually not monitored by humans, and they're in service for years, sometimes even decades. And so the opportunity for a hacker to get in and try to make some kind of a security breach is pretty high. And hackers are discovering that these units are growing in volume, starting to approach, at least from a cellular perspective, the number of units that are out there for handsets and other things. And from a non-cellular perspective, perhaps even more IoT devices than people on the planet today. You're starting to see some government security regulations that are appearing both at the state level in the United States and at the national level, both here and abroad. And these challenges are going to impact the kinds of decisions you need to make, the mistakes you want to avoid for the applications you want to deploy. So let's talk about some of the potential solutions for these kinds of challenges. First, very important, apply security by design principles. Take the best practices as we know them today during your design phase. Don't wait for after deployments. Don't wait as an afterthought to say, oh, what about security? You need to be thinking about security from the get-go. What can happen? What are the mistakes that cyber security hackers could exploit? Those are the kinds of things you need to think about ahead of time. Second thing, which is very important, and I'm going to talk about this more, is that the attacks are going to increase in sophistication as people find more mistakes or open devices that are out there. So in time, these devices are going to be attacked more and more. And because of the longevity of these devices, these applications that are out in the field, they will require updates of some sort. So we strongly recommend, and in fact, I think that without an OTA update mechanism to repair any kind of a breach, let alone add new features, your device is going to have a problem. This is one of the key takeaways that I'm going to recommend for any company who's deploying an IoT solution, is that worry about security from the get-go, and because you know that security problems are going to change in time, implement over-the-air update systems to basically fix any kind of issues that you might have. Finally, what's happening out there is that the regulatory requirements for security are changing. You need to understand them. Find the experts who have started to look at them, like our company has been worried about this issue for quite a long time now. And you need to make sure that those security objectives and those regulations are taken into account, not only from a minimum level perspective, but also doing better than what those expectations are, because you need to avoid going out and touching them or changing them if you can avoid doing so. So let's spend a little bit more time about the specific things that I'm concerned about security, which is that people tend to treat it as an afterthought. That's the mistake. You try to get out there in a hurry, you try to finish your application, get the devices deployed, and get the application on the server side perhaps up and running, maybe your communications pathways are on the internet rather than using a VPN, etc. And you end up creating a solution that can be easily breached. And that's the problem that you need to avoid. Think about it ahead of time. People in the market are responding to these kinds of problems. There are proactive practices for security implementations that have been done in the IT world that can be applied in the IoT world. And that is an incredibly important point to make about that, is that the IoT standards are improving. People are recommending architectures to follow in various spaces. The connected car industry has its set of IoT standards that it's working on, etc. And obviously, there are new government regulations in the works. IoT device security, an example of that is SB 327, which is law, and it'll become enforced on January 1st in this upcoming year, literally 3 or 4 weeks away. And so we need to worry about what kind of IoT device security requirements are required by law, not only here in California, but other states and at the national and other levels, other countries as well. The US federal requirements are still in the works, but you can anticipate that those are going to be also necessary to follow. Now, important point to mention is that IoT risk management has various areas where you can provide solutions. Now, I'm not going to go into detail about every piece of the puzzle over here, but the point is that on the far left, I show you the source of that information, the devices, the IoT devices that are out there. These can be sensors, smart devices, or gateways that collect information from dumb sensors that are perhaps installed in a house or in a building, all the way to the far right where you have the recipient of the information, which could be a human, process data, and there are, of course, computer programs that are taking into account the data that is being received by them and providing data analytics, et cetera. And of course, automation, being able to provide automatic responses to devices out in the field, and all of this stuff in between. Every element in that data chain is subject to cyber attacks and threats. So you have to worry, in your chain is only one element affected, or are more elements affected? And where do you need to implement the kind of security practices that make sense? You need to understand the access points for your organization, whether it is a cloud system that you're working with, or maybe you have a corporate data center. What are the access controls you've implemented, et cetera, et cetera. Designed for the attacks that are likely to occur, and then update as necessary. Obviously, when you go to the far right over here, production servers are easier to access, easier to update. Devices out in the field may need OTA if you're using a wireless transport for your data services. I'm going to get to the next poll before I go to the next topic over here. Where will you be deploying devices? We'd like to get an understanding of the geographical location. So for example, are you deploying only in the United States? Are you deploying in North America, which is Mexico, Canada, United States, and other countries, perhaps in the Caribbean? Are you currently deployed in the United States or planning to deploy them in the United States and looking to scale your application deployments worldwide? Or are you already thinking about planning a global deployment and launching a global deployment in the near future? I'd like to give you all a few minutes to answer that question, and then we'll proceed to the results momentarily. All right, let's talk about the results. Looks like about 90+% of you are focused on deploying in the United States only, and about 8% in North America, meaning outside the US, but Canada, Mexico, et cetera. And not yet any attendees who are looking to scale outside the North American continent. Okay, that gives an idea of the things I should perhaps focus on in the regulations perspective. So let's dive into the next area, device management. When you have some devices that are out there in the field, you have challenges that could occur. For example, if you have a device that is transmitting more data than expected, you maybe deployed a proof of concept, you found the device was doing a few hundred kilobytes per month, and you get out there, and all of a sudden you discover that your average amount of devices that are transmitting is higher than that, or maybe a few devices are experiencing coverage difficulties, and therefore they're continuously retrying and they're transmitting excessive amounts of data. This can affect your communications. This can affect the systems that are receiving the data, your own data systems, perhaps, which are analyzing the data that is being sent from these devices. And as a result, you now have too much data coming in. That's a challenge. So managing those devices that are transmitting too much is something that's kind of critical to take into account. Second thing is that people often forget, and this is one of the mistakes that I think people don't realize when they're busy doing their design and development and deployment. They don't think about the end of life, meaning what happens when that device and now that solution is no longer necessary? How do you remove it cleanly from service? It could be a few years down the road, it could be 10 or 15 years down the road, but if your device is unable to be taken off the network, you may incur costs that you haven't thought about. And of course, in the device management area, when you have success if you have a large number of devices deployed, you're going to need to think about redundancy. I don't mean redundancy necessarily on the devices, I mean redundancy from the servers that are receiving the data, perhaps geographic redundancy, so your data isn't traversing national boundaries. And the analytic systems that may be taking real-time action based on the data coming in, you need to make sure that the capacity constraints that you may create because you have a successful solution could become an issue if you don't worry about it. Maybe perhaps not at the get-go, but certainly plan for it and design for it before you reach that problem. What are the solutions that you can think about? You need a platform, a device management platform, perhaps that is implemented automated device throttling. If a device is transmitting too much data and you could have a cost issue, you might want to implement automatic throttling, slowing it down, maybe shutting it off and notifying your operations and IT folks that this device might be going awry, maybe it has a bad network connection, or it doesn't realize that it's already sent the data, it's not receiving acknowledgements perhaps, etc. These are issues that can create cost overruns and system overloads, and you need to take that into account. Obviously, managing the presence of the device on the network is very important. OTA systems to disable end-of-life devices when they are no longer in services and are still consuming resources and still maybe incurring a cost that is not appropriate for you. And perhaps the coverage has changed. New carrier has been brought into service, which might give you better outcomes from your device transmission perspective, and you need to update the network list in the device. An OTA system to manage the device is incredibly important. And finally, if you want to avoid the redundancy in data analytics services, it is very easy to think about implementing a cloud system solution, and then that would allow you to have geographical redundancy potentially, where you have services that are available perhaps in the United States, separately in Canada, perhaps if you're deploying internationally, you could have data services being provided in European countries. And some of those, by the way, could also support the national data privacy regulation issues that can creep in, which is that if you have a device in a country that requires you to keep the data within the country, using a cloud service rather than implementing your own data center in that country could be extremely important. Device management, I mentioned this already. I think if you look at it from the perspective of what it allows you to do, you have device activation and cancellation. Activation for obviously getting your units on the air, cancellation when they're no longer necessary or end of life, or you want to remove a particular device from service. Obviously, remote updates are incredibly important. You have to worry about deploying security updates and maybe new features, yes, but security updates are incredibly important. And you have to have a campaign. When you send out a firmware or an update to a device out in the field, when you have that OTA campaign manager take that into account, using a company that has provided that capability for you is incredibly important, so you can make sure you're not either delivering data to a data twice or more than necessary, and you want to make sure that you get all of the devices you have out in the field. Again, I will emphasize that end-of-life management often gets overlooked. Think about it during the solution design and deployment time, making sure that if you do have non-functioning units, you take them off the air, because that will reduce your cost in time. Now, I think OTA is so incredibly important, I actually dedicated a slide to it. We have presentations that talk about this more at length. Every IoT program needs the OTA update. There was a time when I used to recommend it. Now I kind of sort of even say to a customer, you should insist on it, because that is going to be essential for fixing bugs, adding new features. If you decide that you want to change a product out in the field, a device out in the field, and really the real reason why it's in this presentation is because of the ability to update the security of that device. If you have a new threat, a new problem that has been discovered out in the industry, you want to be able to provide a solution that can update the device. So you have to have a framework. You have to have a mechanism for delivering that OTA update. Please prioritize. Please make sure this is an important, critical part of your application deployment. So let's talk about the third aspect of the issues that can creep up is when you're dealing with scaling issues. What are the challenges? Finding that you have to have a manufacturer for your device if you want to go get the large numbers of devices deployed is going to be incredibly important. Find that good supplier. The company, if you don't have the internal resources for making your own product, then you may have to retain the services of a manufacturer, a build-to-suit manufacturer, who can help you with getting that product developed and designed and out there, but at the same time has the capacity for increasing the volume as you find success in the market. When you have a device and an application in mind, selecting the various parts of that IoT solution, the connectivity, how is it going to transmit data? The device itself, is it going to be manufactured for you? Do you need a special sensor? What kind of analytics do you need? Ultimately, it is the data that matters. Having millions of devices out in the field where you're gathering data and not acting on them is kind of a useless exercise. You really are dealing with the fact that you're getting a large number of data feeds from various devices, and you need to take the analytics of that data, understand the real-time nature of the applications you're trying to deploy, and get out there and make it all happen at scale. And that's the key over here, making a decision about which cloud service to use if you decide to do one. There are many decisions to be made. And again, scaling to me is another important aspect of an IoT solution, which frankly, we have other webinars that we have done. You can come and take a look at our website on how to scale your application in time. Finally, support. It is very important to keep in mind that if you've deployed 1 unit or 10 units or 100 units, it is easier to provide support for those kinds of devices, not only for your customers, but your expectations of the supplier of the IoT services. But when you've deployed 1 million devices or 5 million devices, then supporting those numbers of devices is not easy at scale. And so your connectivity service provider should be able to help you with this area. So what are the kind of solutions that you should be looking for these challenges? First, begin to ask the device manufacturer all the right questions. If you have a system integrator, great. If they have experience with doing IoT solutions, even better. Can they provide you design assistance? Can they help you with the RF aspects of a design? Because that is often a source of problems when you don't select the right antenna, or you don't understand that RF energy at 850 or 1900 megahertz or multiple gigahertz can be an issue for your product. Is there a special component choice you need to make? Are there special sensors that you need? Do you need to have a size constraint on your device that drives how the manufacturing flow will occur? Does the manufacturer have the capacity to make the products for you? What is their yield rate? What is their rework rate? There's tons of questions that you need to ask the integrators or get help in making that happen. And as I mentioned over here, the right communications choice is incredibly important. Often, it is a cellular service that has been optimized for IoT, like our Fusion IoT network. And the reason I mention that is because it is one thing to make a consumer product that is using Bluetooth going to a smartphone that the user of that device carries, but it is another thing to deploy at scale, unmonitored by human devices out in the field, where you need to manage them to make sure that they're transmitting what you want and only what you want. You have to find the right service provider who can provide you that information, get the data to you reliably with systems that are redundant, and also who has visibility into the network, meaning if your device is deployed in a location which is difficult to get to, can they give you enough information about what's happening to the network in that local area? Perhaps there's a coverage problem or coverage has changed, or is there a network problem that is hurting your device more than somebody else's? Or is in fact the network working correctly? And I'm going to emphasize this a little bit more than I might, but just to mention that quite often we get a service request from a customer who says my device is not working. The vast majority of the time, it is the device and not the network. You need to make that determination very quickly, because that can drive the kind of corrective actions that you take to make sure the device comes back into service. In general, when you have a large number of devices, you're going to need to get a service provider who can provide effective support. You need to have people who have experience with understanding it is a IoT device and not a smartphone, not a consumer device, and not the kind of voice call issues that they might be having. It is related to data transport from a IoT device, and they have to have the real-time monitoring tools necessary to support you. All right, I'm going to give you one example of a kind of decision when you might need to make. For a customer who is developing their own product, you could design it from the ground up. You can go out there, go and get the components, go get your own design team, or if you already have one, use them to design the complete product, the device out in the field, the application on the servers, etc. Or you could buy pre-certified components. radio modules from some company who provides them, the companies who make IoT radio modules, for example. Maybe they already have a board which has memory and a processor available that you can program your application onto. Finally, there's the third choice, which is you go get an outsourced solution, which is an off-the-shelf product. You can go buy a product that already has everything built in, the power supply, maybe a plug-in antenna or a built-in antenna, or you might find design services to help you make that decision about that product. The point is that if you were to go look at the design from the ground up point, the amount of resources you need and the time it takes to get that product built is going to be substantially higher than if you were to buy a pre-certified component or partner with somebody who can provide you an off-the-shelf solution. And if you need to get to market quickly with a small set of devices to explore your IoT application solution success in the market, then perhaps it's easier to start with a partner, then incorporate embedded components and finally design it from the ground up because you want to reduce costs for your device when it's out there. In particular, if you're a startup and you're just getting going and you're resource constrained, find the right partner to start with. That is the advice that we can offer. Build the product, deploy it, build the application, deploy your servers, get the data, and then understand how you might improve and scale later on. Important point to keep in mind, and I will emphasize this over and over again to our customers, that planning for growth is not something you do after you've got your units out in the field. You need to make sure that you take the entire life cycle into account, all the way from design through end of life, whether you're having it manufactured for you, who's going to do the installation, how are you going to operate those devices, what's the analytic systems that you need to put in place, and if you're deploying a solution for an additional end user customer, perhaps an enterprise, etc., how do you build them? How do you collect the information? How do you collect the necessary details to be able to provide that? My point is that you need to do all of this as early as possible. If you plan for growth in the design phase, then you're not going to get surprised by having to make device changes or possibly application level changes when maybe too late, and now you're patching rather than designing it from scratch correctly to begin with. So an important criteria for this is get it done early, ahead of time. Make sure that you have your products understood well enough that you know what you might need to do to be able to grow the number of devices that you have deployed out in the field in time. So in summary, and I noticed that I'm actually going far quicker than I anticipated, which is good. We'll have time for questions. In the security area, the recommendation, the takeaway that I would tell you to do is implement the security by design best practices early. During the design phase, during the development phase, during the part of the IoT solution deployment, when you're getting ready to get it out there, making the manufacturers perhaps be part of the design process as you need, make sure that security is implemented, make sure you have OTA systems, make sure that you've done the right things to be able to fix the security breach down the road. In device management, the one takeaway I would give you is that find a good campaign manager, an OTA campaign manager, because that's going to help you maintain and control costs. The operational cost of doing the remote updates, the operational cost of devices that have been breached and no longer doing exactly what the IoT application needs for those devices to do is incredibly important. And as you need security elsewhere, making sure that you can do updates of your servers, systems, and applications on an as necessary basis. So those are sort of the two major mistakes to avoid. And finally, when you're scaling, make sure that you pick a service provider who can give you the global IoT services that you need. If you're deploying just within the United States, that's one thing. But if you're deploying outside the United States, can you have consistent behavior everywhere across the world? Do you have an IoT optimized cellular data service? And do you have the support you need to get your application deployed? So that's pretty much it, David. I'd like to go back to you to see what kind of questions people have asked, and hopefully we can address them.
All right, yes, like you mentioned, we do have some questions. And reminder to everyone, you can continue to submit those using that Q&A widget. All right, so this first one is asking, how do you recommend that we avoid excessive data transmissions from devices?
That's a very good question. I think that one of the things that we have noticed is that people deploy devices anticipating perfect networks, assuming that the device is operating in a mode where everything is working exactly correctly, and they don't worry about the corner cases. Now, what do I mean by a corner case? What I mean is that you may have a device that tries to connect to the network and send data, and if it fails, it tries again. Well, that can happen. It makes sense that a device can try again. But what could also happen is that the second time also it doesn't work because there's a coverage problem, maybe the antenna has a problem, maybe it's not facing in the right direction, et cetera, and it tries again. Great. That can build up. You can see customers having devices that are not smart enough to understand that there is a reason why their transmission success is not happening. Why perhaps when they receive acknowledgement from the network and that acknowledgement doesn't come, that they do another retry, they should think about intelligent backing off algorithms. Sometimes the data becomes stale. If you have, for example, an alarm and security device, if the alarm cannot get through in a certain amount of time, then the device should say, okay, I'm done. There's no reason for me to continue trying. And use back-off algorithms for making sure that you're not hammering the network with attempts that don't make sense. That could be happening in a way that could overload your back-end systems, because you end up with a scenario where the data transmission from the device is in fact getting through, but the acknowledgement maybe is not coming back cleanly. So the device is trying repeatedly to send the same information over and over again, and now your back-end systems are overloaded. That's one thing. Second thing that we have noticed is that people often have GPS clocks on board with accurate time, and they assume that they can send the data precisely in the same instant from all of those devices. Well, that can overload your back-end systems in a heartbeat. You get all kinds of data coming through the network. You have a distributed large number of devices, and the network handles the data transmissions through it because it's distributed. That's exactly what the cellular system is designed to do. But now your servers are overloaded because every device comes on at exactly the same moment, more or less, separated by a few milliseconds here and there, and now you've overloaded your network. So you want to make sure that that you avoid the scenario where too much data is coming in too fast, and therefore controlling those devices, managing those devices, designing in intelligent back-off algorithms into the device for transmission is important.
Okay, this next one comes in from Joe. What about using devices as relay for other devices to a far field?
Yeah, that happens. That is a very natural usage of IoT solutions. For example, and I'm going to say not only just too far out there, but also, for example, it is cost ineffective for certain devices to be equipped with connectivity capability that is beyond the need for those devices. So, for example, a smart home system doesn't need to have every window or every door have a separate long-range connectivity capability. What you need perhaps is a very short-range Zigbee or Bluetooth or low-power Wi-Fi kind of connection to a gateway device. And that gateway device can then either be a wireless connectivity product using cellular, or it could be a wired connectivity product using the typical ISP that might exist at a home. Now, customers tend to deploy these applications with that in mind. So that's sort of what I would call a hybrid deployment, where you have dumber sensors, if you will, connecting to a smarter gateway that communicates into the network. Obviously, that has some interesting ramifications. The small sensor devices tend to be too small to be able to handle good security implementations, and therefore the gateway becomes the place where you can do a best practice security patch, which makes a lot of sense. And it can also do the kind of capabilities that people are talking about when they talk about remote processing that allows the data to be filtered or perhaps processed and analyzed in the smart gateway, and only the relevant data is sent in. So if a dumb temperature sensor is reporting its temperature every second or every minute, the gateway can decide, aha, when it crosses a certain threshold, then and only then will I transmit. So it is okay to use those kinds of gateways to consolidate your data, to implement best security practices, et cetera.
Okay, this one is it necessary to design a device from the ground up as opposed to buying a standard IoT device?
No, it's not absolutely necessary. However, when you go to scale, that's where it makes a difference. Now, let me explain what I mean by that. If you go and buy a standard IoT device, typically one that has an onboard capability that is sufficient or more than you might need for your application, it has all the power supplies, it has all the connectivity mechanisms, it has a case, it has everything built in, you're generally going to pay a little bit more for that kind of a product than you might if you created a device that was unique to your application. That's one reason why you might want to buy the standard product first and go into your ground up design second. Now, another reason, which is kind of important to keep in mind, is that the standard IoT devices may not have the sensors you need. For example, if you've got a medical device that requires a particular medical sensor, a monitor for a blood pressure device perhaps, or a device that makes a implanted sensor under your skin transmit to a perhaps not your smartphone, but maybe a gateway in the home, then you need to start thinking about designing that device from scratch, because you're going to need to have special needs. You may have size requirements. Instead of the typical standard IoT devices, which I've seen as small as a sort of a eraser, a whiteboard eraser, or a cigarette case size, may still be too large for your application, and you want something smaller than that. You want something more compact. Maybe you need to have special thermal or special shock requirements where the device has got internal bracing to prevent shock. Maybe it's got gel inside to avoid components from being damaged under vibration conditions. All of those mean that you may have to design the device yourself. It'll take longer, it'll cost you more during the design phase, but you may end up with a lower cost product down the road because you made it unique to your application rather than doing a standard product.
Question coming in from Joel. Is there anything for a client to use that can override background parameters? For example, emergency transfers?
It's a good question. I'm not sure if I know how to answer that exactly, but I'll take a stab at it. So let's say that, for example, if you have a unit that has a SIM inside of it that has certain network identified in the SIM, well, in general, you want to make sure that that device follows the connectivity dictated by that SIM. However, there are rules. If you have a product that is being used by a human being, it may need to support 911 requirements. That has to be assessed because it is not a communications device like a smartphone. You have to assess whether it may have to have a smart 911 access capability for a human being, perhaps. In that case, you will need to override the kinds of network coverage that is mentioned in the SIM, because 911 requirement says you have to be able to make that phone call or that data transmission for that emergency service, regardless of the connectivity and regardless of the accounting capability. That's something that is sort of very specific to the application, very specific to the unit, and often it is consumer handheld smartphone-like devices that are governed by this requirement, not necessarily an IoT device. But without knowing the specifics of that IoT device, it's tough to make a very exacting answer to this. We'd have to look at it, and we have people who could help you understand exactly what is necessary from an emergency perspective. I'm going to, as I said, I didn't totally understand the question, so hopefully I answered it to the degree that it was asked about the emergency transfers, etc.
Okay, let's get this one last question in. You mentioned device security regulation. Can you elaborate on that? What are the requirements?
Sure. If you think about it, IoT is an area where the politicians, regardless of where you're located, whether it's in the US or outside, have not yet addressed the kinds of regulations for the products, the applications, the services. Yes, you have unique regulations that are applicable to medical devices, unique regulations that are applicable to the fleet industry, automotive industry, etc. But IoT in general does not have regulatory standards or laws being applied to it. Now, why is that? For two reasons. One is that it's still an early enough area that the politicians haven't gotten to it. It's also an area where IoT can impact a wide variety of markets where there are already independent market regulations for each of those applications that are out there, whether it's related to, as I mentioned, the connected car or medical devices. However, there are situations where the government feels that they can start looking at regulations for IoT devices, specifically device security, because there have been some well-publicized breaches of IoT devices out there. People who are aware of this topic will mention the classic Mirai botnet attack that took place 2 or 3 years ago. There are people who have seen the connected car industry go through some gyrations to implement security in their kinds of applications inside the connected vehicle. So those kinds of regulations which are dealing with security are an easy low-hanging fruit. So the companies who are deploying these applications need to worry about the regulations that are in play. Now, what are these kinds of regulations that are in play? You'll see things that are happening at the state level in the United States. California has recently passed a law that goes into effect, as I mentioned, on January 1st, 2020, where the devices must have certain basic requirements. Now, they've kept these requirements a little bit general. For example, they talk about the fact that the device must not have a easily hacked username or password, or more importantly, during the power-up phase by a consumer who buys that product, they need to be able to change the username and password, and that's required, et cetera, et cetera. Now, meeting those minimum set of requirements is one thing, but if you can exceed them, you're better off, because best practices tend to be more than that. And also the regulations tend to be fuzzy, because they'll tell you, please implement best security practices. Well, they don't tell you what those are supposed to be. And now you have to understand what affects your product. One of the biggest concerns that I have is that what's happening in California is being mimicked by certain other states. There are at least 10 or 11 other states that have picked the California regulations, and 4 or 5 of them, to the best of my knowledge, are almost word for word identical, but the others have a little bit of a twist in them, and you need to make sure that you're making your device be all-encompassing. Now, the U.S. federal government is working on a cybersecurity regulation for IoT devices. It's going to take a little bit of time. The good thing is that they are getting the National Institute of Standards, NIST, to be able to advise them as to what are good practices for inclusion in that law when it ultimately comes out, because then customers will have a uniform standard that can be applied anywhere in the United States. Now, does that mean that it would be perfect to deploy that same unit over in Europe? Well, maybe, maybe not. And so you have to think about those issues. Data privacy is a bigger issue in Europe than it is here in the United States. Security is a bigger issue here than it might be in Europe, et cetera, et cetera. Those all have to be taken into account. Please make sure that this doesn't stop you from deploying the application. What this does is make sure you have a basic minimum set of standards that you implement in the devices and in your applications to ensure that you're out there in the field, your devices don't get hacked, your systems don't get hacked, your communications pathways don't get hacked, and the data does go from the device to the recipient of that information that is necessary.
All right, well, that's just about it for our time today. I want to thank all of our viewers for getting those questions in, and Z for covering those as they came in. Just as a reminder, I want to let everyone know to go to the handout section so you can still download a couple of PDFs there. Also, you will get that link to view this on demand, so if you missed any portion of it, you can review that at your convenience. We're also posting the contest winner in the attendee chat, so look for that. We'll also have that posted in the community on the contest page. So with that, I do want to thank Aeris for sponsoring this great session, and thank you, Z, for your time today. I want to thank everyone for joining, and we'll see you in the future for another partner webinar. So until then, stay safe and keep it spicy. Take care, everyone.
Thank you, David.
Thank you.